Okay, I'm going to present quickly first my laboratory. I'm Raúl Miñón for the Laboratory of Human-Computer Interaction for People with Special Needs of the University of the Basque Country. The laboratory was created in 1985 for the application of computer technology to provide support to people with disabilities. We are 10 full-time research staff who have been participating in several international activities, and our current research topics are ACI and assistive technology, ambient intelligence and ubiquitous computing, and web accessibility. In this presentation, I'm going to work to speak quickly about 3 different research works. Okay, sorry for the ones that has been in the previous presentation because I'm going to repeat the slides of the Cookie adaptive system. Okay, I think that ubiquitous environments have to provide accessible user interfaces valid for people with special needs. We consider 2 main approaches: to create a final user interface for each service and then to adapt it to the needs of its user. And this is not always possible because the system doesn't provide enough interaction resources to provide accessible alternatives. And to create a new user interface from scratch, providing a formal specification of the user interface and alternative interaction resources. This allows flexibility in creating the final user interface, and this is the approach that we follow in the Cookie adaptive system. The Cookie adaptive system is created with the background of the Redis project that was leader in TechnoSite, and the objective is the generation of accessible user interfaces adapted to people with disabilities for ubiquitous services, and is focused on the selection of the multimedia interaction resources. This is the scenario of people with disability entering an intelligent environment with some services centered with his or her device, and is provided an adapted user interface through the Cookie system, and with that adapted user interface is able to interact with all the servers through the middleware CH. This is the technical description of the Cookie system. We have a logical description of the user interface as input and different interaction resources. Then we have an audit rate with the user capabilities, device features, and adaptation modeling, and the resource selector is able to select the most adequate interaction resources for each element of the logical description for a specific user. Then the adaptation engine is able to apply other adaptations that go beyond of the selection of resources and to generate the final user interface. Okay. Sorry for the repeated slides. And now I'm going to talk about the research board adaptation repository. I was in a research stay in Pisa in Italy with Fabio Paterno, and we were collaborating in this research board. Okay, the objective is to reduce the gap between the knowledge and the workload of the developers and the accessible application issues. And the objectives are to provide the community a design space composite of key concepts related to adaptation for people with special needs, to create a repository for collecting different adaptation rules for people with special needs, and to provide access to the repository to allow model-based user interface system the integration of the adaptation rules. This is the design space that we are considering. So, in this design space, as the user disabilities, we consider 4 main categories: cognitive, physical, hearing, and sight disabilities. But then we can specify, for example, a color blindness inside the sight disability category. Then we also consider the granularity level, because it's not the same to apply an adaptation to a single element, to a group of elements, to a presentation, or to an application, or we also consider an external granularity level for the moment when we have to launch, for example, an assistive technology. Then we also consider the adaptation type, considering design time adaptation and runtime adaptations, and also the abstraction level where the adaptation is applied following the Chameleon framework approach. This is the architecture of the adaptation repository. So the idea is that at the same time, a designer that is using a model-based user interface design tool could send the user interface, for example, the concrete one or the abstract one, and specify I want to adapt this user interface for a people with blindness, for example. Then this user interface is sent it to the adaptation environment. There was a user interface descriptor language normalization step. So, for example, a people using XML or Maria or UIML could send the user interface descriptor language. Then the adaptation manager selects for this disability and for this abstraction level, which are the adaptation rules stored in the adaptation repository. And then considering the granularity level, there is a police for ordering that rules. For example, if a granularity level has to be applied in adaptation rules have to be applied at the group level, it's better to apply first the group level to before the single element level, because if not, you will lose the chain. Then the adapter applied the adaptation, and there is a user interface descriptor language inverse normalization to came back to the original UIDL language. At runtime, the process is just the same, but instead of selecting for which disability I want to have my interface adapted, it sends the context, and in the context is describing the disability, the task, what it's doing, or etc. For example, an example of adaptation rule could be where a person that is sitting in a wheelchair starts to walk, to move with the wheelchair. Then the user interface will be automatically changed from the graphical modality to the vocal modality to be able to interact with it. So we think that the innovation of this approach is that the provision and integration of adaptation rules in third-party systems is compatible with the specific needs of the users and the diverse target platforms, support change in the context, and abstracts in the accessibility issues to the application designers. And in this URL, later I can provide you if you want, you have some samples of adaptation rules, the complete presentation of this work, and more things about this. And I don't know, we have internet? Yes. You should. I don't know if it's the correct one. Okay, let's continue. Or not. Yeah. Okay, yeah. Here we have the different examples of adaptation rules. So in each one of them, you can see the event condition action related to each rule, and also you can see you can download the rule that is described using the AAATE language created in the Serenova project. So, and then we have also here the design space and the presentation. Okay, the last project I'm going to talk about is ModelAccess. ModelAccess is a project funded by the Spanish Ministry of Education and Research. It's developed by the University of Basque Country and the industries Natura and Urea Center Workshop. The objective is to create user models from web access logs by means of data mining techniques, and to adapt presentation, content, and behavior using an extension of wide area marking language. The target population is people with diverse type of restrictions due to disability, aging, or content limitation, and that experience problems to access to the web and use its content. Okay, the technical description is this one. There has been developed a Firefox add-on developed for gathering user interaction data, such as mouse movement, scrolling. There is a web service implemented for applying adaptation techniques to web interfaces. There is an ontology defined for determining which adaptation techniques to apply for a given user. There are data mining techniques used for analyzing user interaction. There are web interfaces annotated with wide area marking language extension, and 99 adaptation techniques have been identified, classified, and integrated into the ontology, and 48 of these techniques are fully implemented. The innovation is that one-time web interface personalization based on real user interaction data, a comprehensive repository of adaptation techniques, and an ontology defining a user model and reasoning about the adaptation techniques to apply. Thank you. Any question?